Hi, welcome back to Moose and Chemistry. This is Empirical and Molecular Formula, lesson number 1. Empirical formulas, what are they? Empirical formulas are the simplest form of formulas, using the simplest whole number ratios. On the other hand, molecular formulas show the number of atoms within a molecule that are not often in the simplest whole number ratios. Let's look at our first problem. A compound has an empirical formula C2H5N. And the molecular formula has a molar mass of 86.16 grams per mole. What is the molecular formula? Well, we know the empirical formula, so we also know that the molecular formula has this mass right here, 86.16 grams per mole. So the first thing we need to do is find out what is the empirical formula mass for C2H5N. So let's go ahead and do that. We take C2, and remember that carbon is 12.01 grams per mole. Okay. Hydrogen, we have 5 of those, so that's H, there's our 5, times 1.01 grams per mole for every hydrogen. And then nitrogen, we only have 1 of those, so N is 1 times 14.01 grams per mole. Alright, so let's go ahead and add all this up. Alright, so this gives us 24.02 grams per mole. This gives us 5.05 grams per mole. And this gives us, of course, 14.01 grams per mole. So when we add all this up together, you get a grand total of 43.08 grams per mole. Pretty snarly, eh? All right, so now we're going to take this 86.16 grams per mole and we're going to divide it by 43.08. So 86.16 grams per mole, and we divide it by 43.08 grams per mole, and that gives me approximately 2. So then what we're going to do is we're going to take the formula C2H5N and multiply each individual element by 2. So C2 times 2, right? H, 5 times 2, and N, 1 times 2. So our molecular formula is going to be C4H10 N2. All right, pretty cool. Let's look at another problem. Calculate the molecular formula of a compound that has an empirical formula, C2H2O, with a molar mass of 126.12 grams per mole. So this number, let's keep this number in mind, okay? So let's go ahead and figure out the molar mass of C2H2O first. So C is 2 times 12.01. H is 2 times 1.01, and oxygen is 1 times 16.00. And this, of course, is going to be in grams per mole. So when we do all this, this is going to give me 24.02 grams per mole and 2.02 grams per mole, and this is going to give me 16.00 grams per mole. Alright, when we add this all up together, we get 42.04 grams per mole. Now we get a little bit of flashing there. I'm wondering if the power's getting ready to failure. So we're trying to get this video done as fast as possible. So let's take 126.1 grams per mole divided by 42.04 grams per mole. And that's going to give me approximately 3. So what we're going to do is we're going to take C2 times 3, H2 times 3, and oxygen 1 times 3. This is going to give me C6, H6O3. And that's it. If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly, and we'll see you back here at Moosing Chemistry!